All right, 5-3, bisectors of a triangle. So let's start off with some vocabulary. All right, looking at the figure below, does AB or is AB the perpendicular bisector of CD? Well, that is false. Is CD the perpendicular bisector? So it intersects AB as midpoint. That's true. So that means any point on CD is equidistant from A to B. That's true. All right. What does concurrent mean? Concurrent means occurring or existing at the same time. So in math, when three or more lines intersect at one point, they are called concurrent. All right. So we're going to use the words concurrency, concurrent, or concurrently. Two classes are concurrent when they meet at the same time. The point of concurrency of three streets is the intersections of the streets. A person may go to school and hold a job concurrently. Okay. All right, number 7 is an example of concurrent. Number 8 are not concurrent. And then number 9, also not concurrent. All right, theorem 5.6, concurrency of perpendicular bisectors theorem. So the perpendicular bisectors to the sides of a triangle are concurrent at the point equidistant from the vertices. So perpendicular bisectors PX, PY, and PZ are all concurrent at P. So let's mark ABC to show all congruent segments. All right, so let's look at this first one. Perpendicular bisector creates two congruent segments. Perpendicular bisector creates two congruent segments. Perpendicular bisector creates two congruent segments. Now, we also know that at the point of congruency, all of these points here are congruent. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So there we go. All right. So what are the coordinates of the circumcenter of the triangle with vertices 2, 7, 10, 7, and 10, 3? So let's go ahead and graph those points first. So let's graph the point 2, 7. So here's the point 2, 7. There's the point A. 10, 7. Here's the point B. And 10, 3. Here is the point C. So let's connect those dots. Okay, so draw, done. Label the points at the midpoint of AB. So halfway through AB is 6, 7. 6, 7 would be the midpoint. Okay. And the midpoint of BC would be at 10, 5. Okay. So label the coordinates of the midpoints. Done. Draw the perpendicular bisector of AB. So since this is on a coordinate plane, we know that is the perpendicular bisector. Okay, done. Draw the perpendicular bisector of BC. So we know this is perpendicular. Bisector, done. Label the coordinates of the point of intersection. So here is the point of intersection at 6, 5. So the circumcenter of the triangle ABC is at the point 6, 5. All right, so notice the circumcenter is the point of intersection of the perpendicular bisectors. Okay, problem number 2. A town planner wants to place a bench equidistant from the three trees in the park. Where should he place the bench? So we know the trees form the blank of a triangle, the vertices. We need to find the point of concurrency of the perpendicular bisectors, because that will be equidistant. So our plan is we're going to find the circumcenter of the triangle, which is equidistant from the three trees. All right, so the town planner can place the bench at the circumcenter of the triangle formed by the three trees. All right, theorem 5-7, concurrency of angle bisectors theorem. So the bisectors of angles of a triangle are concurrent at a point equidistant from the sides of the triangle. So angle bisectors AP, BP, and CP are concurrent at P. That means PX must equal PY, which must equal PZ. All right, so complete this statement with the following words. The point of concurrency of the angle bisectors of a triangle are called the incenter. The point of concurrency of the angle bisectors of the triangle is always inside the triangle. So the circle is inscribed in triangle ABC. All right, so let's see what we got here. Here's the picture here. I know that Q is the point of concurrency of the angle bisectors, so that means Q must be the incenter of the triangle JKL. And I know that the distance from Q to each side of JKL is equal. So that means QO must equal QM. So if QO equals 5x plus 36, then we know that it also equals 2x plus 51. So I'm going to subtract 36 from both sides, and I get 5x equals 2x plus 15. Subtract 2x from each side, 3x equals 15, so that means x equals 5. All right, so let's find QO now. So I know QO equals 5x plus 36. So QO must equal 5 times 5 plus 36. So QO equals 25 plus 36. So QO must equal 61. All right, so draw an inscribed circle in the diagram with the right. All right, so we're going to, here's the center of that circle, and here are the radii of that circle. So there we go. Done. Circle the correct relationship between QO and QP. QO is less than QP. So the radii measure 61. Since QO is one of the radii, QP is longer than the radius of the circle. Therefore, its length cannot be 50. All right. So a triangle circumcenter is outside the triangle. What type of triangle is it? Let's draw some examples. So let's draw an acute triangle. Let's use this point. Here's 1, 1, 3, 0, and 2, 4. This will be an acute triangle. All right, let's draw an obtuse triangle. So let's use the points 2, 1, 4, 1, and 0, 3. And let's draw a right triangle. Let's do the point 1, 1, 4, 1, and 1, 4. Okay. So the point of concurrency of the perpendicular bisectors of the side, that is the circumcenter. Underline the correct word. When a triangle circumcenter is outside a triangle, it will be what? I don't know. It's going to be obtuse. Okay, so we have the perpendicular bisectors. So here's a bisector is perpendicular, bisector is perpendicular, bisector is perpendicular. So the point will be inside for an acute. Okay, bisector will go here, bisector will go here, bisector will go here. So for an obtuse, it's outside, inside. And for a right triangle, the bisector will go here, so here, let's go here, and let's go here. So it's going to go on. Okay, and that's it for this section.